Good morning. I'm Michael Cade. I'm also a Senior Global Technologist at Veeam. We sit in the Product Strategy team. So I'm going to spend the next probably 30 minutes talking about NAS backup. Now, who thought they were going to come to Tech Field Day and talk about NAS backup in 2019? I think the key to what we're doing here is we don't really do anything unless we can do something better or differentiate against what else is in the market. So again, in true everything that we've done so far, a sub-agenda. So we're going to talk about why now? What do we have today? So everything that I'm going to talk about after that first slide is what's coming next with V10. We're going to talk about the components, get through actually what makes up this. We're going to talk about the actual backup process and how we are differentiating against everything else in the market. Then we're going to get into the restore scenarios with a demo of that restore, and hopefully I've got time to show you a bit more about what it looks like and how we've blended that simplicity into our NAS backup, and we've not created a completely new way of our existing Veeam admins to go and look at how they protect NAS today in their environments. And then if we really do have time, then I'll touch on what else do we have around search, monitoring, reporting. So what do we have today in terms of pre-V10? So we have the ability to send files to tape, really not very scalable, like literally log files to a tape or really simple file copy type scenarios, really not scalable. We also have NDMP to tape. Again, not really the newest and best way of being able to move data around and protecting that. It works, it ticks a lot of boxes of being able to push NAS workloads into tape. But again, we've got all of the characteristics of an NDMP backup that we have to forego at that point as well. And then again, we don't have single file restore. Okay. So because it's NDMP, we don't have the ability to do any single file level recovery against that.
Sorry, could you just go through that sentence again so we can edit the video?
Yeah, sure. So what do we have today? I've already said about the file to tape. So it's not really scalable, doesn't really get to the enterprise level of customer that we have today, the 365,000 plus customers that we have that have that requirement of protecting those files. What we also have today is NDMP to tape. Now this ticks a lot of boxes for those large enterprises that have that big tape library, that have that absolute requirement to get that data from their NAS over NDMP into tape, but it has the same limitations that NDMP has today, that whole entire volume restore and backup, and no granularity in terms of being able to send stuff, being able to restore individual files. So I'll quickly brush over this. Obviously, this is a mantra from us, right? Simple, reliable, flexible. How do we make things, everything that we do, every product every feature, every product has to align to this mantra. That's simple, reliable, flexible. There's some bits in there. Obviously has to be software defined. It obviously has to be, we have to think about fast recovery, but to be able to provide fast recovery, we also have to be able to do the fastest possible incremental backup of that large NAS environment as well. And it also needs to be flexible. There's a lot of different NAS sources out there, so we need to be flexible in terms of how do we protect them. So looking at the challenges today around NAS, I guess we get a head start because we haven't got to go and redevelop or re-engineer anything that we have, because for 13 years, we've had very limited exposure in that NAS market. Customers, either SMB or mid-market, they would re-architect, they would push things to a Windows file server, they would re-architect to an image level based backup, which worked. They gave them all the functionality that we've had today in the vSphere world. And then later on, we enabled our agents to be able to protect physical Windows or Linux file servers. What this gets us into is those big NAS devices, the likes of ONTAP from NetApp, Isilon, HNAS from Hitachi. There's endless amounts. I know there's a lot of storage guys in the room, so you know the ones I'm talking about. But that gave us the 5 challenges that we need to consider when it comes to NAS backup. How do we process petabytes of unstructured data? How do we get that data from A to B without it taking weeks or days like it does in an NDMP world? How do we then scale that? Because we need to be able to scale that accordingly, depending on the size of the customer. Now, we've got a lot of customers that may only have up to 250 gig, right up to multi-petabytes. So we have to make sure that the same components that we use are completely scalable from end to end. The biggest challenge is how do we make it as fast as possible? That incremental, how do we make it as fast as possible? How do we provide consistency? That's kind of a big thing for a backup. We have to make sure that that backup data is as consistent as we absolutely can possibly make it. And how do we make it cheaper? How do we give the option to put that data wherever it needs to go? Again, going back to that whole agnostic, yes, we have to go to some sort of storage, but how do we make it the choice of the customer to pick and choose where they want that to go? Whether that's a dedupe device that we integrate with, whether it's the public cloud from a cloud tier point of view or an object storage point of view, but really giving that option, that choice to our customer. So I'll quickly run through the components. So one of the things we took the approach of is not just going to back up SMB, we're not just going to back up NFS, we're actually going to look at, right, there's a lot of SMB out there from the likes of ONTAP, likes of HNAS, etc. There's also a lot of NFS file shares out there that leverage the same storage systems depending on what the environment requires. And you can see the versions in there as well that we use. But also there's also a large amount of enterprise customers that use Windows file servers and Linux file servers. So the ability to be able to protect them all using exactly the same wizard, and when we get into the demo, I'll show how that looks and how it looks from a Veeam admin point of view today. So how are they going to first see this when V10 comes, and how can they start protecting their NAS workloads as fast as possible in that simplistic way? What we also have is these advanced transport modes. Now, we have 3 options, all configured on a per share basis. So we have backup directly from the file share. Now, this is just we don't care about locked files. Let's just take the backup. We will go back and we'll retry those locked files, but it's a very quick way of being able to take those backups. Some workloads will allow us to do that. Some companies will be okay with that and miss those locked files because the next backup run will capture them. Then we have the ability, and I'm going to get onto a bit more about what that file proxy looks like and how we leverage that file proxy to lift and shift that data. But we could leverage VSS snapshots to be able to take a consistent copy of that NAS share. And we've also got the ability, so where you're using NFS, where there is no VSS, then we've got the ability to leverage native storage snapshots. It's done by a script, but we can go to that snapshot that's exposed and use that as the source to pull the data out. Remote VSS, the storage vendors that I've already mentioned, the Hitachis, the NetApps, they have the ability to leverage remote VSS. So that means we can use the middle option and still be able to leverage their storage snapshot technology to be able to pull that data as a source, which means we're getting that point in time, but also that consistent copy of that data.
Will this platform support Nutanix Mine?
Yes. So Nutanix files. Nutanix Mine is the target, the HCI play, which just has Veeam sat on top. Nutanix files is a source that they have where they expose SMB out. Absolutely. This is, again, we needed to make that as agnostic as possible. They expose their snapshots, so yes, in theory, we can leverage that functionality there. So how do we do that? So obviously, from a first backup point of view, we have to take a full backup. We're good, but we're not magicians. The cache repository is where we're going to keep something called a CRC tree, a CRC hash of everything that happens in that production. So we have to walk the file system to begin with. There's not one person, not one competitor out there that can do it any different. So we have to walk that, and that builds our CRC tree or our checksums. Then on our incrementals, we leverage the checksums to match against the next CRC tree that we've built. So we're only understanding what's changed in the files or folders underneath. So we're only going to be able to take, or we're only going to take what's changed since, and that's what makes it really fast. The key point to this cache repository is a simple repository. It should be as close to your production source as possible. My advice is that it should be the fastest disk possible, but again, completely agnostic. We really don't mind, but obviously your performance will vary depending on what disk you put that on or flash. Everything stays in RAM, And these are set, again, on a per share basis. So you can have multiple cache repositories in multiple locations that serve and just store that metadata or that checksum, that CRC tree that we do the comparison against. So to go into a little bit more detail around that. So we can see from the top down, from that share, down through the files, through the folders, what has changed since. And there's a diagram when we get through this. But what this allows us to do is take them really, really fast incremental backups. That then allows us to scale from the small scale NAS environments right up to those multi-petabytes of unstructured data. But it also allows us to get to that fast incremental that I've been talking about.
Could you just explain what you mean by incremental?
So anything that's changed since the last backup.
Right. But when we talk about incremental on a system basis, we'll look at individual components that have changed and only store the differences. When we look at it at a file basis, people typically will take an entire file and back that file up when it ends up in the target repository, even if 1 byte has changed within that file. Now, depending on the type of data that you're backing up, if it was just spreadsheets and stuff like that, backing up in another megabyte or kilobytes probably isn't too bad. But when you get into larger environments that have got multi-megabyte, even terabyte files, you're in a different world. So when you take that data, what are you actually taking and storing?
So so we're not storing anything in the native format either. So I'll get to how we're storing it, and that will maybe answer. If not, we'll come back to that. Was there another question?
Yeah, so, and I'm sorry, I may have just kind of drifted. So what is detecting the changes? What component of this is detecting that something has changed on that end system that you're trying to back up? Because there's no agent on the machine, right? So what's monitoring the fact that a file has changed?
So
you've got a cache of all the CRCs. How are you detecting that a CRC of a file has changed, therefore the file has changed? How you're reading the file?
So the hash that we create on the source,
yes,
that we then compare to it's called a .v cache that sits within the repository. They compare.
So how are you regenerating that CRC to know that the file's changed?
Okay, so if I just build this out, that may answer, may not, and we may need to get back to it. So again, we've got our production file share, and we've got our CRC tree. So full backup, we have to walk the whole file system, right? We have to understand what's changed. We have to understand the file structure. We have to understand all the folder hierarchy as well. We create something called a vcache. Now we come around to that, whether it's 8 or 12 or 24-hour incremental backup window, and we see that file 4.1 has changed. We then create another vcache at that point.
I think I know
I think some magic just happened here. We see that a file changed.
So you scan everything.
So you scan the file
one more time, right? to check every single file.
So you had to generate a new CRC for the file in order to know that the file changed, unless we trust the magical Windows archive bit, which we all trust, right? So what are you reading that file again in order to generate a new CRC, in order to know that the CRC changed from what you'd stored in the cache previously?
Yeah. So we have.
So what is reading that file? Is it does the cache repository server do it?
Yes. So the cache repository has something called a source agent on that is reading that file share, whatever that file share is. Like I say,
So it's reading it across the network. But your previous slide said the cache repository doesn't process any data.
It doesn't. The file proxy processes the data. So this just builds the vcache.
So the proxy, so your proxy would ideally sit as close as possible to the data sources to minimize latency and anything else to get that data off.
Yeah, as well as affinity.
It's got to churn through an awful lot of data.
Yes, exactly. So the cache repository builds this vcache. This is the understanding of what's changed since the last backup, so the incremental. So we've seen that file 1 has changed. The magic has happened. The source agent has detected that. And then we then...
If I have a directory with 1 million files and you change a file, it's a massive amount of
If each is like a gigabyte in size, so you're reading 1 million gigabytes of data every single time you want to check the files changed.
We can see from that CRC that we've built what's changed in the hierarchy.
Oh, yes, but
Yeah,
this
but-
is why I told you a file in a directory. I mean, you don't change the other directories because you see that CRC of the directory is not changed, so anything changed underneath. But actually, in that directory, I have 1 million files. And I have to backup one single file out of that million. That means I have to scan.
We have to understand what's changed.
Yeah.
We have to find what's changed.
So anyway, it's a lot of work, and it's a lot of IOs on the system anyway.
So I've got some stats that we'll get to at the end if we've got time. If not, we can definitely share that afterwards as well on what the beta looks like and how that is performing in those circumstances. We've gone as well, it's not just typical file shares. We're looking at medical data, which is just generally one share with loads of images in. So there's no folder hierarchy. So we're looking at different circumstances there as well. So we'll follow up on that. So then we, again, compare and then we take that backup. Or what the cache repository actually does is instruct the proxies or proxy to then move the data from source to our repository. So this is where the file proxy comes in. So notice how the logic is coming in through the cache repository. That's then instructing the file proxy to go and pull this changed data. Now, obviously, from a first full backup, that file proxy is going to just take everything. And we can scale those file proxies out. Today, these are Windows proxies. These are Windows operating system. Can be physical, can be virtual, but they are Windows only. We are exploring the fact, can we use Linux proxies? So one of the things that's coming in V10 that's aside from this, but worth mentioning, is that we will have VMware Linux proxies to be able to process image level backups within vSphere. So we're already on that process of looking how we can use Linux proxies from that point of view as well. So this is how we scale. So the file proxy looks up, and the next slide actually shows you a bit more logic around this. And this is also where the consistency lies. This is where the health check happens against the source and to the target. So how we look at that, if we scale out our file proxies, and these could be a mix of physical and virtual as well. But really, all we care about in the file proxies is the CPU. The CPU is what controls the concurrent tasks of the folders of the file share. So now you'll see where potentially that healthcare type environment changes, but we can share, each file proxy can share CRC trees. So we can pull the data concurrently between these file proxies and land them not on the cache repository. That's meant to be a short-term repository. So the short-term retention is our first landing zone. This is where we're going to start putting generally our 7.14 30-day type retention. This is where we're going to be really concentrating on our versions and what file retention we need to keep. It's different to the VBK. So the VBK format that is leveraged in a VMware and physical world, an image level backup, this is not the same file format here. And that was a consideration that we had to make, is that if we've got multi-petabytes, we can't then put that into a huge VBK format, our own backup file format, because then that removes the functionality and the portability that we bring with this. The capacity tier can be used as this short-term retention, but we will ignore anything that Anthony and Rick spoke about before around we would not go into offload anything to object storage in that policy that's set there.
What is SOBR again?
Scale out backup repository.
Say it again.
Scale out backup. Yeah, so yeah.
Thank you.
So then we've got the ability, so based on versions. So everything is based on a version here. So we set our retention, and if I get into the demo, I'll be able to show you what that looks like. Based on that version count that we want to keep locally on that short-term retention, we then tier everything off into a longer-term retention. Now, that longer-term retention in the diagram is an object storage. Again, this could be S3 compatible, this could be AWS S3, this could be Microsoft Azure Blob Storage, this could be IBM Cloud S3. But it also could be a dedupe device. It could also be a simple repository. It could be just some direct attached storage. What we've also got is the ability to exclude files and folder or file types and folders from the short-term retention, as well as even further going down the exclusion path in the longer term retention. What we've also got the option to do, and these are options, you don't have to go to the long-term retention. It's really going to depend on the actual source and the requirements of backup that you need. We've also got the ability to do the secondary copy. Secondary copy might be a copy of that retention to another site, so that you've got at least one day's retention or one version of that active file in a different location, so you can recover from that if DR failure scenarios were to happen. Again, it's an option. It can be the same retention as the primary, but it can be granular in terms of we can change what that retention period is. What this also can do is we can encrypt here with one key, and we can choose to encrypt this with a different key. So again, a level of being able to protect against insider threats. And this is really the key here, is this: by being able to have the choice to bring whatever storage you want or need, that's ultimately going to allow you to define how much you want to spend on that backup storage. Obviously, you can buy very cheap storage and get potentially lower performance, or you can buy very expensive storage and get really high performance. It's a pick your own poison type challenge there. Now, version control. So I mentioned around this, and this is how we work here from a versioning. So the short-term retention always has that latest version for obvious reasons. That's where that first line of defense is going to be. That's how we're going to recover things as fast as possible. That doesn't mean that you can't use a storage snapshot as that first recovery point, but the enterprise customers that I've been speaking to over the last 12 months around this, where they've got too much NAS data to even consider a backup product, because NDMP just takes far too long, too many hours. They're using snapshots, they're using snapshot replication, and okay, that's fine if you're coupling that with a backup solution, but it's probably not the safest against all failure scenarios. So from a version point of view, if we're taking our backups, and let's just say that file is changing on a daily basis, and our retention is actually 3 days on our short-term retention. So obviously we write that last version 4, and then the policy then says, let's tear that off into our longer-term storage. Now, take an ISO, just a pure example, doesn't change, and our retention is 3. The only way that is going to ever land down into the long-term retention is if it's deleted from the source. Once it's deleted from the source, then it will move down into longer-term retention. But that's what the internet's for anyway, right? ISOs. So to quickly go through this, because I know Anthony wants to get on and talk about CDP. So what does this look like from a file format point of view? So we have our NAS backup job, our repository. So if we were to go into our repository, as you can see, that image shows what that looks like. We have our backup job. Then within that backup job, we have a GUID, an identifier to what that data is. The vStore allows us to describe the whole backup file. What is it? What share is it come from? Where is it go? Like, everything is stored in there in terms of ACLs, permissions, etc., what we've gathered from that. Then if we break down into that, then we've got our vSource, which is going to describe the metadata within that file. And then we've got a data and we've got a meta folder. Break into that folder, then we have a v-index, and I've got a summary of this so we don't have to. But each of those v-indexes and the v-slices describe the actual data in that other folder that gets here. So then we have something called a v-blob. That v-blob is a 64 meg chunk of data. And it sits within that data, or this GUID, which is a 1 gig basket. This is allowing us to align ourselves to object storage and be able to really be that ready to get into that way of thinking. And it's also very scalable in terms of being able to store the data in that fashion. So yeah, scale to billions of files, that's a quote there. But I've already mentioned around the VM backup format, the VBK it's not suitable. Like, the size of NAS devices that we've got out there are multi-petabyte. That we can't store that in one WinZip type scenario, which is very much how we describe our VBK format. And if we were to open up a a Veeam NAS backup, you'd have those multiple 64 meg chunks. Now we do have smarts that understand, depending on what that repository is. So if that's a simple repository and a version is aged out, then we can go in there and we can take it out of that block. That's fine. We can manipulate that file. But if it's in a dedupe device, then we can't. We've got to wait until it's appropriate to do so. And then if it's object storage, we've got to wait for it to just age. We've got to wait for that whole blob to age out. But we've been very granular in terms of 64 meg is the smallest we can actually get to make it as efficient as possible from that point of view as well. How does it work? So yeah, I've said about the massive parallel processing. We can use as many file proxies as possible. Now, I mentioned around the first fall. I'm seeing a lot of people, a lot of RSCs and a lot of the field actually deploy even more, like as many Windows proxies as they possibly can, because then they get all these concurrent tasks just going at the NAS share.
I'm confused. I'm confused. So are we talking about, I have a server, I got an application. That application is backended by a NAS server, NAS storage system, whatever, right? All the data's over here on the NAS. So are you talking about backing up the data once it's here, just taking the files and not necessarily going application by application? Or so their files, because that from a backup perspective doesn't make sense to me.
No, so this is more around NAS file shares, so home drives, user data, it's that element. So because the application we can deal with our agents, with our image level backup.
Okay, so it's just straight up, if my H drive is on this NAS, you're able to go and back whatever that is on the H drive, even if it is an application, whatever, you're just taking the storage in the NAS.
Yeah, the raw files, we're going to take the files.
Once it's there and changing, okay.
We do have the ability, though, where there is an application that we don't have an agent for or the ability to back up, we have the ability to do pre and post thaw scripts that allow us to coerce the application, so then we can take the backup. So we've got the data.
Okay.
But yeah, the use case is NAS file shares, home user drives, documents, etc.
That makes way more sense to me. Thank you.
I have a doubt on performance. I mean, do you already have benchmarks? I know this is a preview features right at the moment, but you know, when you talk about we can scale up to billions of files, how does it take to build this proxy cache that you need to?
So that first backup file is what allows us to build that first V cache, and then the incremental will depend on how much changed overnight or whenever that next backup window runs.
Oh yes, but by understanding how much does it take to build the first one, you can guess, you know, depending on the number of modification you make, you know, on how is structured the NAS file system, you can understand. Because my problem is that if all these files are organized by an application, okay, so we have plenty of legacy application writing files, and they use the file system as an object store. You really have thousands, millions of files in a single directory sometimes, or strange structures for which you have a directory and then multiple directory underneath. You change this file in the very, very low, the sub directory. Actually, you change the seriously of the first one, so you have to grow to crawl everything.
Yeah, I think so.
I know it's a limitation of the file system. It's not.
We're gathering them performance data so we will understand a bit more when we get to market and get even more field interested in seeing what the possible is, and there'll be calculators around there to understand that. If you notice that in the cache repository, everything sits in RAM. So the more RAM we throw at it, the more that CRC can sit in RAM and in fast memory. So, but yeah, the beta at the moment is limited. It's an internal beta, so only RSCs can control that and put that out there. We've got some good feedback on terms of how fast that is, and I can share some of that as well. But yeah, I think.
But they are talking about enterprise file shares usually.
Yeah, we're talking
a lot of Office files.
Yeah, we're talking like as a source. We're talking Isilon. We're talking NetApp ONTAP, we're talking HNAS from Hitachi.
Okay.
So there's a point on that as well, is do you have any integrations with some of those vendors, for example, with NetApp or others? Are they supporting that somehow natively, or are you just running that as if it was, let's say, a dump file system? Where you
Yeah,
need to
so we
scale
have
up?
no integration other than scripts that we
Okay.
have to use. So we can go and trigger, but we use so there's APIs out there that allow certain, we could use like Snapdiff, for example, to be able to enable this for a faster way of being able to understand what the change has been. We're exploring what this can achieve first from an agnostic point of view before we have to make an engineering decision to write against that integration. We want this out in a fashion that will allow us to see what the performance looks like and then look at what the next version looks
Yeah,
like.
but however, if you don't have any kind of integration, you're scanning that at a regular interval, right? So do you think that it can cause some load on some of the NAS servers or systems? Because not everything is, you can have a NAS which is a small server running somewhere under a desk, or it can be an enterprise NAS.
So one of the ways that we've alleviated that pain is we have a backup IO control, so we can see so we can throw as many proxies at something as you like, but if you bottleneck that production NAS, then you're not serving any data.
Okay, I'm going to hammer with more questions. What is backup IO control? Because how can you be aware of the current IO levels on a NAS?
So we understand what the bottleneck is. So we understand that we can turn down. So we might give a proxy that's got 16 vCPUs, and then that can take 16 concurrent tasks at one point. And if that's let's say a low-end NAS device, then we're going to that's going to be in a bad shape because we're going to be taking all of the I/O from that. So what we can do is we see that, and then we can we can turn down those vCPUs that are used on that specific NAS share. So we stop. We want to take a backup, but we don't want to kill the performance of production. So we've got that. I'll try and get to that to show.
Okay.
Yeah, because I'm kind of torn, because I like the kind of completely agnostic approach of saying, hey, we're just a client, and we can detect everything without any vendor support. And at the same time, it's almost like the least efficient possible way of doing it, but it works with everything.
So
If you sort of mean, like, I can read all the files and I can take CLCs of everything, which works regardless of who provides it and what the file system is. I can support NFS, I can support SMB, whatever it is. It's great. On the other hand, if you can get those integrations, you can probably speed that up by a factor of 20.
100%. So from a VMware point of view, that's exactly how we started.
Yeah.
We started with no storage integrations at all. Then we went down the route of integrating with storage vendors. And we have a large, we literally partner an alliance with all of them. So there's a strong roadmap behind this.
All right.
We kind of touched on that. I'm just conscious of time.
Yeah, sorry.
What I'm gonna do is I'm gonna go through the restore piece, and then I'll go back to the demo and see what time I've got left to show as much as possible. So another key part is obviously how do we restore, and the challenge is NDMP, we can restore everything back to just its original location or a like for like type system. So we wanted to make sure that we could do an entire restore, but not back to the original location. So being able to be choose where that location is. And that's going to recover all of the permissions, the files, the folders, etc. The ACLs are along there. And it's going to put the latest version of that backup or that restore point back into that share. So just worth mentioning here is a lot of RSEs or a lot of the field are asking about migrations. How can we move from this NAS source, Windows file share, to a NAS device, an SMB, or potentially to a cloud file system, and being able to do it that way. So that was something that generally comes out when we're talking about Veeam features and products. Other ideas start coming into play. The other option is this rollback to a point in time. So like a quick last known good configuration type rollback. This is the demo that I'll run. Is if your shares are infected by a ransomware attack, and it encrypts all of your files, the quickest way for me to get back is just hit the last known good configuration button and roll everything back. So that's what that does. It just allows us to say, we notice what's modified in kind of the reverse fashion to that CRC hash. We can understand what's changed since the last backup. So let's just send everything back to that last known good configuration, or that last known restore point. And then obviously we've got the ability to do files and folders, be very granular. We're using our own software and our own tool set to do this. What we're doing at this point is we're not mounting any of the actual backup data. We're loading the metadata, which allows us to do something quite cool in that because we can load all of the metadata all time, all of the restore points at once, we can actually see all of those different versions across all of the different repositories that they live in. So whether they're in the archive, whether they're in the secondary, whether in the short term, we can then go and see what the modified date was, what the size of that is, and then be able to then do a restore from that point of view. We've also got restore from Enterprise Manager, but this is more of a visual as well. So this gives us the ability to give a portal, but also the search functionality out to our users or groups within our environment to be able to then go and search against a specific restore point and then find the file that you want and then restore that. Download it locally. What this also gives is a good visual of what we're doing from how much are you backing up, where are we storing it, it will say what's in the short-term repository, what's in the long-term, how many files are we backing up, etc. But also that we can also define restore roles out to those specific groups so they can only see specific files and folders that they can restore from, as well as leverage that RESTful API on there. BeamOne, Rick mentioned BeamOne on there. One of the biggest things is understanding what's changed since the last backup, or just generally understanding what the hell's happening in these large NAS environments. How do we understand what's changed, what that change rate looks like, so that we can have some visibility of that? BeamOne allows us to see what that amount of data looks like, how much we're processing, where the bottlenecks are from a file proxy point of view, whether we should add more. There's also some automation built in there where we could say we need like an alert to say we need to build more file proxies to deal with the concurrent tasks and the scale of the source. It also give you reports on those backup repositories, and they can all be scheduled out. If you've been using Veeam for the last 13 years, it's click, 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 and you're backing up your data, right? 15 minutes, I think I've heard or seen someone talk about is within 15 minutes, I can have Veeam up and running on a Windows server and I can start protecting some workloads. Pretty powerful stuff, but obviously the more larger environments, that complexity then starts getting a little bit different. But ultimately, we add our file server. In fact, this looks better. And this is where we choose whether it's SMB, whether it's NFS, whether it's a Windows file server, whether it's Linux. So I've got some already created here. If I go into one of these, obviously we point it to the share, and you can go into as granular into that as you need. We give it the access credentials. That just needs to have read credentials. Now, read will not get you, if you need to restore back into that, you need to have the relevant backup operator rights to be able to push that data back into that location. Under advanced, that's where you see those three versions. So you've got the backup directly. That's where applications allow for those lock files. Maybe the backup admin doesn't care about that. He's just going to ignore those lock files, or we're just going to continue to retry. We could leverage the VSS snapshot if we're using the correct file proxy, or potentially the remote VSS of the storage array. Or we could leverage the backup from storage snapshot if their snapshot folder is exposed. So you can see there, I'm using a script to create a snapshot that's in the backup job that will then go and trigger that snapshot. It will always be called Veeam NAS backup. I'll use that as the source, as that point in time. Then to go to your point, Max, around backup IO control, I would touch on what the file proxy looks like as well, but this backup IO control allows us to choose how many vCPUs, how many concurrent tasks do you want to push on this share. Because if that's a low-end NAS, you probably want to be closer to the left. If you want to, and BeamOne will give you the insight into what that, if we're hammering the production NAS, but people will start phoning if that happens. But then if you've got one of those enterprise NAS devices, then put it up to the top. automatically default, we leave it as optimal, which allows us to use the concurrent, the CPUs that we've established in the file proxy. This is also where we determine the cache repository, and also because shares can be anywhere across a federated or distributed environment, it might be that you need to pick certain file proxies that can only access the shares in London. We only want London proxies to be able to pull that data from there. So we have that granularity. Then under backup proxies, so in a familiar place, we have our file proxies. Under here, we have our properties. This is where we set our concurrent tasks. This is, again, if I hover over that, you'll see that it's based on the CPU cores that we have. I can flip that up. There's 4 CPUs in there. If I go above, it'll give us a warning. So we'll try and do more, but we're going to give a warning to that as well. We've got the ability to do traffic rules in there, but I imagine our network admin is probably going to change it for us so that we only get what we're allowed. But we can be quite granular around how our traffic is moved between the environment as well. And then just to quickly run through the backup job and what that looks like. Again, very similar to what our image level backups look like. We give it a name, we choose our file and folder. Again, this is for demo purposes, but these could have multiple shares, multiple folders in there. We've got the ability to include or exclude masks. You can see that I'm saying I don't want any MP3s or MP4s. Now this is where we determine what versions do we want to keep on a short term, what versions do we want to keep on a long term, and then we've got the ability to go even granular from an exclusion point of view to say, right, okay, I said I didn't want MP3s and MP4s in that short term. Now I don't want AVIs or I don't want .docs. So we can be really granular, and you can say also around active file systems, active files, as well as deleted files as well. Secondary target, which is our backup copy job into a secondary location. We can change the retention. We can use a different encryption policy here as well to protect against insider threat. And then you set a schedule, and then off that goes. What I'm going to do is, so I've got my typical home user drive, right? A blog post, you can see it all looks very, very strange to be showing, dude, where's my NAS gone? But you can see that it's all good. Everyone's working on it, everything. So I've written a little ransomware script that will go away and encrypt all of those files in there. And I'm just going to go back to that last known good configuration, that rollback, to get that data back up and running. So if I first, let's encrypt that. So this is just going to simply encrypt that, and I'm going to show you what that looks like as well, because so you can see all the modified data will happen in there as well. See that all of that changing. If I now open that view, that was lucky. Yeah, can't publish that. It looks terrible. So back into Veeam, we've got our backups. We've got our ransomware demo. Here's one I made earlier.
But did you send the bitcoins?
Sorry?
You send the bitcoins to get it.
Yeah. So roll back to a specific point in time. This is going to load up the wizard. It's going to give us a snapshot of what that looks like. So I know that it's in that file. So I can drill down into that. We saw that all change to 7:30, whatever, 7:44 lab time. So we can see that this gets us back. But you've also got the slider here to go between other restore points. So we choose that latest. And then what that's going to do is that's going to take those file backups and throw them back into our affected share. And then I've just opened this as well, in fact, while we're doing that. So then I went on, so the other recovery method is files and folders. So the ability to actually dive into here, we can always load the latest restore point. We can select a specific restore point, or we can do an all-time. This allows us to see all the different versions that we have of that file. Here's one I made earlier. So this then allows me to go in and I can actually have a look to see what actual version of the file I want to recover. Now, demo, ignore the size. They're all the same. I've just added a line of text in each one that says version. But you can see that my retention in that backup job is 3 days. So I'm keeping 3 days on premises. So the 13th, the 12th, and the 8th are all on the backup location, which is my short term. and then I offload into our archive or into longer term retention, and that continues that retention. We can choose, if we chose to copy to, we can actually say I want all of them versions and I want to send them to a different location because I want someone to actually go through them and give us the insight into that. But fingers crossed, you can see all the modified dates. So that's a good sign that this demo actually worked. So if I now open that same file, we're all back up, back in business.